The diagram below shows the graph of y equals to fx. This curve passes through the origin and has a maximum turning point at 1, 1 and a horizontal asymptote y equals to 0, which really just means an asymptote that is along the x-axis. So we are asked to sketch on separate diagrams these three different transformations. Let's explore them one by one in the subsequent slides. Okay, we are going to first start with y equals to fx, and the next transformation we hope to do is to transform this graph into x plus 3. Usually, if you recall the AMA method that we introduced to you earlier, we always do the x transformation first before we do transformations that will affect the y coordinate or the y transformation. So what would this transformation cost? So if you recall, such a transformation is description of a translation, and this translation is by 3 units. In this case, because it's an x transformation, we say that the graph translates to the left, or we say instead of saying to the left, we will say that it translates along the negative x direction. So really what we are talking about is all of this x coordinate 0, 0 is going to shift by 3 units. So over here, sorry. So that isn't right. So it will shift and give a new coordinate such as 0, negative 3, 0. For the x coordinate, for the 1, 1 coordinate as well, it's going to shift by 3 units to the left. So I'm going to end up with a maximum turning point that is translated. So similarly, the shape of this graph doesn't really quite change. So the maximum turning point changes as well, and the shape of the graph remains exactly the same. So the next transformation that we want to explore is from the next transformation would then be for a scalar factor 2 to the translated fx function. So what this actually means is we are going to do a scaling, scale the graph by a factor 2, and this time we say that it is along the y axis or the y direction. So this is the description of the translation, which also means that I'm going to multiply all the y coordinate by a value 2. So you'll end up with a new maximum turning point that is stretched by the value 2, and also what used to be the origin. In this case, because the y coordinate is a 2, is a 0, and you multiply 0 by 2, it doesn't change, so it remains the same. So somehow this graph is stretched a little bit more, and the y coordinates are kind of by 2, but do remember that the asymptote doesn't change. So the asymptote y equals to 0 remains as an asymptote. It remains as an asymptote. Let's start with y equals to fx again, and this time round we are going to do a translation that requires us to multiply by the x coordinates, or the x with a -1. So if we recall this translation, it is a reflection of the fx graph, or the graph before, about the y-axis. So what we have now is a reflection about the y-axis, and the origin will of course remain. However, the turning point is going to be reflected and end up as negative at -1, 1. So let me do a dotted sketch of this translated graph. Okay, and subsequently, if I am to reach the graph that they require us to produce, it would then allow and require us to add 3 to the fx function, which really just means also a translation. By 3 new units, but in this case, it's along the positive y direction. So really it just means let's shift the entire graph up by 3 units. So I'm going to move 1, 2, 3, oops, -1, 4. And the origin also has to move by 3 units, 1, 2, 3, which is now going to give me the coordinate 0, 3, and the shape has to remain the same. And what is interesting is we must remember that there is an asymptote that is given by y equals to 0 originally. So this asymptote has to remain as well. And let me sketch the asymptote by hand. And this new asymptote is going to be given by the equation y equals to 3, of course. And such would be the shape of my graph. Pardon the drawing. I think we could have done it a little better, but go ahead and give it a shot.
In this transformation, we're going to do a combination. So we're going to start with y equals to fx first, and what it now requires us to do is our first transformation for the variable x, and I'm going to multiply by half to it. And what this really means is we are doing a scaling. So this is a scaling, or sometimes we call it a stretch. And we use the word scale factor, isn't it? And for x transformation, what is interesting is that if this is a half x, the scale factor is a 2, so an inverse of half. And this obviously would happen along the x direction. And if we want to look at the two coordinates that's given to us, 0, 0, that would also mean that I'm going to multiply the x coordinate by a 2 in this case, because it's origin, it's at 0, it doesn't really change. But if we look at the maximum turning point, what happens is I will multiply by a 2 to its x coordinate, so a transformation of such happens to its turning point. And let me mark it out here as 2, 1. And the origin doesn't quite change, so we are talking about a scaling, or rather a stretching of this curve that passes through the origin. The maximum turning point did not quite change, and it stretches a little bit wider along the x direction in this case. So this will be the first transformation. And in this question over here, there is a second transformation that we want to look for, which is going to convert y equals to f half x and multiply the y coordinate in this case now by half. So I'm going to then now affect the y coordinates to this graph. And the description to such a transformation would also in this case be called a scaling. And we scale the graph, the blue dotted one, by a scale factor, in this case equivalent to half, and we do it along the y direction. So what this also really means is that we are going to multiply the y coordinate by half, and for the origin it doesn't change, but for our coordinate maximum turning point, which is now 2, 1, I'm going to multiply the y coordinate by half, so it is going to be transformed in this manner. And so what I have over here, let me draw this transformation in red, and the turning point is now going to be 2, 2, half, and the maximum turning point, the origin doesn't change, and you will realize that this graph remains the same shape, but what happens is it is now flattened by quite a bit, half of the blue dotted graph originally, and it is going to have the very same asymptote, y equals to 0, and it remains, and the asymptote is really our x-axis. So this is the final transformation, and whatever the question requires from us in this case.